Okay, students, now let's discuss about the recursive algorithms and how to analyze the recursive algorithms. So we already know a recursive algorithm is an algorithm or a program which calls itself in its own body. So for example, if there is an algorithm, say um, A is an algorithm, and this algorithm is going to perform something. So for example, it is going to check some condition. If for example, n is greater than 5, then it is going to call itself on some small, it is going to be, say, sorry, for example, n by 2 or plus a of n minus 1, and so on. So in that case, this algorithm is said to be a recursive algorithm. With respect to the recursion, two things are very important. One, we must have a base condition or a stopping condition. If we do not have this stopping condition or a base condition, what will happen? This will fall into an infinite recursion, right? Which we have seen in programming in Java as well. So a recursive algorithm must always have a condition first, then it will call itself. Like for example, if this algorithm A on n is not going to check any condition and it is going to call itself again, and then no matter whatever it does, it's going to call itself in for infinite time. It's going to call on n minus 1. It's going to call on a of n minus 1. So it's going to be infinite recursion. So we have to prevent this we have to take care of this infinite recursion by adding this stopping condition. Stopping, sometimes we call it anchor, or sometimes we call it base condition, right? These conditions are very, very important. So this is what actually an recursive algorithm is. Now let's see, if a recursive algorithm is given, how should we analyze the recursive algorithm? For that, I'm going to take some example that we already are familiar with. Let's say, for example, the algorithm is given something like that, a method to compute the factorial that we are already familiar with. So the factorial algorithm is like this. It returns an integer. The name of the method is, for example, factorial. To compute the factorial of the n. So what I'm going to do, I can say, hey, if this n is equal to 0, or maybe less than or equal to 0, or you can simply say the equal to 0. Let me just make it equal to 0. Then in that case, simply return 1. Right? So simply return 1. In another case, do it recursively, right? What to do? Call yourself recursively on n minus 1, and whatever the answer you get, just multiply it with n, right? That's what simple algorithm that we have for the recursion. So like in the non-recursive algorithm, we were using the sum equations. For the recursive algorithm, we will set up the recurrence relation. Recursive relation, right? So first of all, the first step in order to analyze recursive algorithm is to set up a recursive relation, right? What is a recursive relation? It's basically a mathematical equation to show that this algorithm is recursive. And how to do so? For example, I'm going to take the example for this factorial algorithm. What I'm going to do, I'm going to say, for example, I'm saying, hey, if t of n time is required to compute this factorial of n, then what does this mean is, this is going to do two things. There are two conditions. One condition is when n is approaches to 0, when n is equal to 0, and the other condition is when n is greater than 1 or greater than 0, right? When n is greater than 0. So what am I supposed to do when n is equal to 0? I am simply returning 1, meaning I am doing an operation which is to return some value. That operation costs a constant amount of time, let's say 1, right? This one is not returning of 1, this one, no, this is what, this one is the cost of the return operation. Okay, in other case, when n is greater than 0, what we are doing, we are actually doing two operations. What are those operations? The first operation, the first operation is we are going to call itself on n minus 1, on a smaller instance. So what I'm going to say, hey, what you are going to do, if t of n is required to compute fact of n, then t of n minus 1 time is required to compute factorial of n minus 1. And in addition to that, I am performing this multiplication, which cost something, I have to add that cost as well. And since this is an arithmetic operation, for that, the cost is constant, which is 1. This is called a recursive relation. So this is a recursive relation to compute the time complexity of this algorithm. Now, how we are going to do so? How we are going to find the time complexity? Let's do it now. So with the help of this recursive relation, I can say that I can now solve it mathematically. I can say, hey, if t of n time is required to compute the factorial, then of course t of n minus 1 time is required to compute the factorial of n minus 1. And then I have to multiply it with 1. For that, I have the cost 1, which I'm going to add it, right? So I'm going to call it equation number 1. Right? Remember one more point here. In order to solve this recursive relation, there are many ways, right? There are at least 3 ways or 4 ways that we can find, that we can follow. The first way that is called backward substitution method. Backward substitution. Right? Backward substitution method. Another way is called forward substitution. Forward substitution method. The third way is called the recursion tree method, right? And there is another way which we are obviously not going to learn here, is called master theorem. This is a theorem to prove to find out the recursion. So in this course, we are just going to focus on the backward substitution, right? So I'm going to use this backward substitution method to solve, to compute this, to find out the time complexity of this factorial method. Now, what does backward substitution method says? It says, hey, if you are interested to find t of n, go 1 step backward and see what time is required for that. What does that mean? In place of n, I'm going to substitute n minus 1, because the backward step, if n is the current step, the backward step would be the n minus 1. So what I'm saying here is, I'm saying, hey, t of n minus 1, I am going to substitute n minus 1 in place of n. So what I'm going to get, obviously I'm going to get in place of this n, I'm going to substitute n minus 1. So this will give me n minus 1 minus 1, which is going to be n minus 2, right? T of n minus 2, and plus 1 is always there. Let me call this equation 2, right? And now let me go 1 step back, 1 more step backward. So if I move 1 more step backward, that would be t of n minus 2, right? So now in place of this n, I'm going to substitute n minus 2. If I substitute n minus 2 here, it's going to give me n minus 2 minus 1, which would be t of n minus 3. Plus 1 is already from there. Let me call this equation number 3. Right? So first step. Now, let me list down the steps here so that we can understand. First step. So step number 1. Formulate recursive relation. Right? Step number 2. Solve this recursive relation. Let me call it R, recursive relation. And in order to solve, I'm going to use backward substitution method. And in this method, the first step is go 1 step backward. And the best way is to repeat this for 3 times, so that we can find out these 3 equations. Now, once we have find out these 3 equations, what I can do now? I can do some algebra here. Let's say, for example, what I'm going to do, I'm going to substitute equation, the equation 2 into 1. Equation 2 in equation 1. What do I mean by this? What is my equation 1? Let me just rewrite it here so that we can start this step process here. T of n is equal to t of n minus 1 plus 1 is my equation number 1. So what I'm going to do is, I know the value of this t of n minus 1 now, which is this one. So the value of t of n minus 1 is already known to me, which is this one, right? So in place of this t of n minus 1, I'm going to substitute this whole equation. So what I'm going to get here is t of n is going to be t, in place of this t of n minus 1, I'm going to substitute the value, which is t of n minus 2 plus 1. And this plus 1 will also be there, plus 1, right? So let me just clean it up, plus 1. So it is going to give me t of n minus 2 plus 2. So that's the equation that I got right now, which is for t of n. Now, once I have reached here, what I can do, I already know the value of t of n minus 2, which is this one. Oops. The value of the t of n minus 2, which is this one. So I can substitute this value here. Now, how can I do that? So I'm going to do t of n is equal to, in place of t of n minus 2, I'm going to substitute the value, which is t of n minus 3 plus 1 and plus 2. This one should also be there, right? Plus 2, which is going to be t of n is equal to t of n minus 3 plus 3. You will be able to see a pattern here. Now, if I keep on continuing this, if I keep on for t of n minus 4, n minus 5, keep for some value of k, t of k, what I'm going to get, in place of n, I'm going to substitute k, t of k minus 3, right? And if you see here, oh, sorry, t of n minus k, right? So for t of n minus k, because I'm going to substitute t of n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, and at some point at n minus k, what I'm going to get this value. How I get this one? So if you note the pattern here, if it is t of n minus 1, it is 1. If it is t of n minus 2, we have 2. T of n minus 3, we are going to have 3. So if it is t of n minus k, this should be n minus plus k. So if I am able to reach here, from here, what I can do now, I know from my recursive relation, which is here, I have to get rid of this t term, right? I have to get rid of this t term. And how can I get rid of this one? I can actually get rid of it if I am able to reach to 1. And how can I reach to 1? That I have to find out. What does that mean is, if I am able to find t of 1, which I can substitute 1 simply from my recursive relation. So how can I make this equation to t of 1? That is my goal. I can do some algebra once again now. I have to find out some value for this value of the n, value of the k, so that I can substitute something in place of k, so that this whole becomes 1. So what does that mean is, I'm actually interested to find out what should be n minus k if I want to make it 1. Right? So what should be the value of k if I want to make this whole 1? So it turns out that I can simplify it, which comes k is equal to n minus 1. So if I substitute k is equal to n minus 1 in this equation, this whole will become 1, right? So let's see how can I do that now. So now in place of this, I'm going to substitute t of n is going to be t of n minus, in place of k, I'm going to substitute n minus 1. Right? Plus, in place of this k, I'm going to substitute n minus 1. Right? This is going to give me t of n minus n plus 1 plus n minus 1. Right? That's what I'm going to get. Now, this n and n is cancelled out. What is remaining is t of 1 plus n minus 1. Right? And now, I know this t of 1 is actually equal to 1. That is given here in my recursive relation. Whenever we are going to get 1, I'm going to substitute 1 here. So now, in place of this t of 1, I'm going to substitute 1. It is going to be 1 plus n minus 1. This 1 and 1 is cancelled out. Whatever remaining is n. So I can simply say this belongs to O of n. Right? How I reach this O of n? I actually solve this recursive relation using some algebraic or some mathematics, and I came to the point where I remain with the equation only, which is either a linear equation or a quadratic or a cubic, so which remains only n here. So I say that this is O of n. Now let's take one more example to understand it further. Let's say, for example, let me write it over here. Let's starting from here. So for example, one algorithm is given and I have computed the recursive relation out of that. The recursive relation given here is, let me say this is my example 2. Another recursive relation is given. T of n is equal to T of n minus 1 plus n whenever n is greater than 1, n is greater than 1, whenever n is greater than 1, and it returns 1 only whenever n is equal to 1. So this recursive relation is given, right? And now I am interested to solve and find, I mean, this obviously this recursive relation is written for some of the algorithm, right? Because of the shortage of time, I just directly have written the recursive relation here. You already know from the previous example, if an algorithm is given, how to find out the recursive relation out of the algorithm. Okay, now I want to solve this to find out whether this belongs to what is the time complexity of this one. So I can simply say that, hey, T of, let me find out the equation first. T of n is equal to T of n minus 1 plus n. Let me call this equation number 1, right? And now I have to follow the backward substitution. So I am going one step backward, meaning I'm going to substitute n minus 1 in place of n. So n minus 1 in place of this n is going to give me n minus 2, right? N minus 1 is going to n minus 2. Plus in place of this n, I'm going to substitute n minus 1. Let me call equation number 2, right? Now, one more step backward. So one more step backward means I'm going to say T of n minus 2 is going to be T in place of the n, I'm going to substitute n minus 2, which will be n minus 2 minus 1 is going to be n minus 3, plus in place of this, and I'm going to substitute n minus 2, which is going to be my equation number 3. Now I will substitute the equations and then I will solve it using the algebra. So what I'm going to do, I'm going to substitute equation number 2 in equation number 1, right? So if I substitute 2 in 1, what will happen? T of n is going to be in place of this. Okay, let me just write equation number 1 here so that we can see what is that. So T of n minus 1 plus n. This is equation number 1. And now I know the value of n minus 1, which is this one, right? So I'm going to substitute the value of T of n minus 1, which is this whole equation. So that means it is going to be equal to T of n minus 2 plus n minus 1 plus this n, right? So I got this one now. All right. Now, I already know the value of the T of n minus 2, which is this whole equation. So I'm going to substitute this one now. So I'm going to say, hey, this is going to be equal to now T of n minus 3 plus n minus 2, and this whole is remaining, which is n minus 1 plus n. That's what I have got. Now, if I keep on doing this for some value of k, where n is equal to k, so what will happen? What I will get? I will get T of k is going to be equal to T of, you are able to find the pattern now here. So if this is n minus 3, this is n minus 2, I mean n minus 1. So what does that mean is, I'm going to substitute the k value here. So I'm going to say, hey, n minus k, if this is n minus k, the next term would be k plus 1. Like for example, see here, if this is 3, the next term is 2, the next term is 1. If this was 2, the next term was 1. So if this is k, the next term would be k plus 1. That is what I am going to do here. Plus n minus k plus 1, the next term, right? Plus so on, plus n minus 2, right? N minus 1 plus n. That's what we are going to get. Now, if we are able to do so, then what I have to do now is I have to find out the value for n, for value for k, for which this whole becomes 1, because I need to get rid of this t term. And I can only get rid of this t term if I find out the value of k now. So it gives me something 1 like this one, right? So that what should I do now? Let's see. Again, the same thing. For what value of k it's going to become 1. And we have already seen in previous example, for k is equal to n minus 1, it will become 1. So I'm going to substitute k as n minus 1 here in this equation. So that means I'm going to get now is t of, in place of n minus, in place of k, I'm going to substitute n minus 1, right? Plus in n minus, in place of k, I'm going to substitute n minus 1 plus 1, right? N minus 1 plus 1 plus so on, plus n minus 2 plus n minus 1 plus n, right? Okay, now what's next? I can simplify it now. T of n minus n plus 1. This is going to be n minus n plus 1 plus 1 plus so on, plus n minus 2 plus n minus 1 plus n, right? So now if you simplify it, n and n is cancelled out. What remaining is t of 1 plus this n and n is cancelled out. What is remaining is 1 plus 1 is 2 plus so on, plus n minus 2 plus n minus 1 plus n, right? Now we know the value of the t of 1, which is given in the recursive relation here, which is 1. So in place of t of 1, I'm going to substitute 1. So 1 plus 2 plus so on, plus n minus 2 plus n minus 1 plus n. So if you observe this equation now, this equation is nothing but the sum of first n natural numbers, right? So 1 plus 2 plus 3 plus 4 plus 4 up to n 1, right? So this is nothing but this is whole is going to be according to the mathematical formula is going to be n into n plus 1 divided by 2. Why? Because the sum of first n natural number is n into n plus 1 divided by 2, right? And if you try to solve this one further, it's going to be n squared plus n divided by 2. Since we are going to find the worst case time complexity, which is big O, so I am going to ignore rest of the thing, and I will say, hey, this belongs to O of n squared, right? That's how we are going to find out the recursive algorithm. So in order to compute the time complexity of the recursive algorithms, we will use the recursive relation. In the recursive relation, you can solve it by any means, but in this course, we are going to solve it using the backward substitution method, and we have seen that how we can solve that. All right. So in this module, we have seen what is an algorithm. We have seen how to analyze the algorithm. Then we have seen what are the complexity classes. Then we have seen how to solve, how to compute the complexity of the non-recursive algorithm. And then in this video, we have seen the last video of this module, we have seen how to compute the complexity of the recursive algorithm. Now you can as a homework or as a practice, you know how to find out the Fibonacci numbers, right? Fibonacci of n, which is basically Fibonacci of n minus 1 plus Fibonacci of n minus 2. So you can draw a recursive relation and try to compute the time complexity of Fibonacci numbers. And similarly, you can see, you can solve, you can compute the recursive relation for all the recursive algorithm, recursive program that we have done in our programming 2 class. Open that up, find the recursive relation for your practice, and solve and compute the complexity of those algorithms. All right, so we'll be back with the data structures first lecture about arrays and array lists in the next week. Until then, take care and bye.